right, so this one initially looks an awful lot like this problem over here. But something is different. Do you notice what's different between this equation, which was this one we had a rational expression, right? We have a polynomial in the numerator and a polynomial in the denominator. In this expression, is this a rational inequality? Or are each of these terms rational expressions? Well, you know, I could rewrite this, couldn't I? As x divided by, I could write this as 1/4 x plus 3/4 is greater than or equal to 1/3 x minus 2/3 plus 1/4. Right? So if I just have x to the first power, and I don't have x in a denominator, this is no longer these are no longer rational expressions. These are just linear expressions. So if the denominator does not contain an x, you don't have to solve it like this one, where you had to get everything on one side, right, and then set up your boundaries, right, and create your sign chart to be able to solve it. This is essentially a linear equation, right? Not a nonlinear, but it looks like a nonlinear. So I thought I would introduce this one. So here, I can just multiply both sides by the least common denominator, which of course is 3 times 4. They don't have anything in common, so we'll have to take the product. We've got 3 in the denominator, we have 4 in the denominator, so 3 times 4, 12 is our least common denominator. We can multiply by 12, unlike the other equation, inequality, because there is no issue, no unknown about our denominator being positive or negative, right? There's no confusion. It's positive. We got a 4, we got a 3. Positive, all right? So we're not going to be having to, we don't have an unknown in our denominator, so it's not like our denominator, maybe it's positive, maybe it's negative. And do we reverse the inequality? We're multiplying by 12. 12 is a positive number, right? So there's no worries here. Is greater than or equal to. So we're just going to multiply everything by 12. This one's going to be a lickety-split. I'm trying to color code it a little bit. I have to keep grabbing the right marker. And of course, every time I put the markers down, you hear bang, bang. All right, now let's just simplify. All right, so we can reduce that. All right, so 4 divided by 4 is 1, 12 divided by 4 is 3. 3 divided by 3 is 1, 12 divided by 3 is 4. 4 divided by 4 is 1, 12 divided by 4 is 3. Multiply! And we have 3 times x plus 3 is greater than or equal to 4 times x minus 2 plus 3. Now we can just solve this. So 3x plus 9, we'll distribute the 3, is greater than or equal to 4x minus 8 plus 3. Combine our like terms. 3x plus 9 is greater than or equal to 4x minus 5. If I subtract 3x, I'm not going to have to worry about reversing the sign, the direction of that inequality at all at any time in this equation because I'll never be dividing by a negative number. So if you keep the x positive, and sometimes you can't do that, you won't have to worry about reversing the inequality. So 9 is greater than or equal to x minus 5, right? I don't have to do any dividing at all. I'm just going to add 5 to both sides. So x is less than or equal to 14. Let's do our number line there. And so that was, I'm not going to start at 0. Let's start at 5. 6, 7, 8. I think I regret starting at 5, even 10. Let's see if we can fit it. 11, 12, 13, 14. And it is less than. So I get to end less than or equal to. So you won't see me doing the bracket thing, parentheses, because I just do it so terribly. But if I was going to use a bracket parentheses number line, that would have been a bracket. All right, and that's the end of this one. So this one was not a nonlinear. I threw this one in just sort of so you could, well, not to trick you, but so you could see that every time you see a fraction, right, it's not necessarily a rational expression. If there's no variables in your denominator, this is just linear, and there's no, and the exponent is 1. This is really just a linear inequality, right? And so you'll solve it simply by, isolating x, right? So that's the end of this podcast, this video. So thanks for watching. Bye for now.